Is the sound working? Okay, good. Okay, welcome everyone, and thank you for coming to this session. My name is Ola Hallengren, and I'm going to talk here about performance enhancement in SQL Server 2022. So, yeah, here's some information about me. I work in an investment bank in Copenhagen, working with SQL Server for a long time, different versions, both in the cloud and on premises. So can I ask, how many of you are using the new version SQL Server 2022 in production? Okay, a lot of people. How many switched to new compatibility level, 160? Okay, that's good. That's good. Okay, so in our company, we have upgraded all our systems, apart from some vendor application, to the new version, and also switched everything to new compatibility level. So we're running our core trading systems on SQL Server 2022. And I'm going to walk through here the different improvements in the new version. Some of them I'm sure you already know about and have heard about in other sessions. Some of them maybe you don't know about. And I will also share some of our experiences. Some things are working well, some not so well. And if you have questions, please ask along the way. There will be like some different sections, so please try to ask in those small breaks. Okay, so let's start here. So I made like a summary slide here, actually 2 summary slides. What are the, you can say, as I see, top improvements? So one thing is you have this improvement availability group around the redo. Now they have like a thread pool. We will look a bit more close on that a bit later. They have some big improvement to Tempdb related to GAM and SGAM pages here. They have improved the buffer pool scans, so it's now parallel, much faster. There are improvements to ADR. So can I ask, are you using ADR? Many of you are using ADR? Few people? You know what it is? Okay, let's talk a little bit more about that later also. There are some recent improvements to stack dumps, especially for filter dumps. This came here in CU8. And okay, so some more improvement. This is more like the optimize or intelligent query processor related things. So there is this PSP optimization to handle or mitigate parameter sniffing. There are those feedback features, memory grant feedback, C feedback, and DOP feedback. And all of those are using Query Store now to persist the data. There are some improvement to plan forcing for Query Store. They have optimized that. And also some improvement to automatic plan correction, actually something that got into CU4. So this is like another feature that's maybe not so well known. Any of you using this automatic plan correction? Okay. And some more improvement to Query Store. Now you can add hints in Query Store. So yeah, there are some more improvements also, but this is, as I see, the top improvements. Okay, so let's start with this availability group, parallel redo thread pools. So how it worked before is that, when availability group came out in 2012, then this redo process on the secondary replicas was like a serial process. And that was not so great for performance. Then in 2016, they came out, so it was now parallel. So that you can say, how it works, transaction logs, records are coming over to the secondary replica. Then there's this redo process there that's running and like reading transaction log and like moving the data into the data files. And that's now a parallel process. So this was really great improvement in 2016. The problem was that it was not really working that great if you have a lot of databases. Because how it works is that there was 100 threads in total. And you can get up to 16 threads per database. That means that you can only have 6 databases that actually got parallel redo. So what happened then if you have more databases? Well, they got serial redo. So you have, let's say that you have 8 databases. Then you got 6 databases that got 16 threads each. Then you have 2 databases that only got a single thread each. That was not great. And you could not control it in any way. And to make it even worse, it was, you can say, who got it and did not get it. That was like based on the startup order of the databases. So what we saw typically is that some smaller databases with not so much activity, they started up faster, and they got a parallel redo. And some of the very busy databases did not get parallel redo. So that could be very unpredictable, especially if you have maybe a smaller number of databases first, and things are great, and then you create a few more databases, and then you're not getting this parallel redo for, for some of the important databases. So this is like the problem. So what did I do? So in SQL Server 2022, it works differently. So instead of assigning those redo threads, you can say, for each databases, they now have like a global pool for the whole for the whole server. So those 100 threads would be like in a global thread pool instead. And then you can say whoever needs it, you can say, or the database that needs it the most will get the most threads. So it's more dynamic. And you don't have to do anything to get this. It's just out of the box in 2022. And I've been doing some monitoring here to see how it works. So, yeah, this is just a script. If you want to see how many threads different databases are getting, either if you are in 2019 or 2022, you can use this script. Then you can see in 2019, you can see that like static per database. And if you're looking at 2022, you can see it like it's changing. If you run it again and again, number of threads will be different for different databases. And I was looking at this in some of our big systems. So this is on a server with 144 cores, logical cores. And I was looking at 3 different databases over 24 hours. And you can see number of threads. You can say on the, axis to the left, and then the time on the axis to the right. So you can see that for the first database, that is a really busy database. Then you can see that when it's getting the most threads, it's getting 17 threads. And this is not documented, but it looks like there's some kind of maximum, at least on this size of server. And then you can see a certain period when there's a lot of activity, it's like getting 17 threads all the time. And then there's some periods with less activity. Okay, then it's getting less threads. Right? So this is really good because it means that someone else can use those threads when there's not so much activity. And some of the other databases here, further down, there's less activity. This one has less activity, and this one has even less activity. Then you can see like the one below. You can see most of the time it's only using a single thread. But in some periods where there's some activity, then it's using more threads. So this is really good improvements. Okay, moving on here. So Microsoft have been doing several improvements to Tempdb in the last few versions. There has been, I think, also in the beginning, there has been issues with contentions around Tempdb. That's why Microsoft have recommended that you create multiple files and so on, like as a mitigation on some of those, you can say, system pages. So in 2022, they improve how it works for the pages that they call GAM pages and SGAM pages. So before, it's like only one process could, you can say, access them at a time, and then you can get contentions on those pages. Now in a new version, it's like multiple sessions, multiple processes can access at the same time. They have this, concurrent updates, and that's just a great performance improvement. We have not been doing any measurements, but before we upgraded to 2022, we had a critical incident once in a while related to Tempdb, and we have not seen any of that after we upgraded. So I think that's really, really good improvement. And again, also for this feature, you don't need to do anything. It's just out of the box in 2022. So basically, all feature that is, you have certain feature that just get out of the box, and certain feature that comes with a compatibility level. So how to know which features just out of the box and which one comes to the compatibility level. So how to think about it is that all feature that is changing the plans, new optimizer feature that is changing the shape of the plans, they are typically behind the compatibility level. Other engine improvement that not really affecting the plans, it's just out of the box. That's typically how it's working. So another of those engine improvements is there is something called buffer pool scans. So basically, in certain situation, SQL Server need to scan the buffer pool. So for example, when you start up the database, if there's a failover, there's backups, Tempdb, certain situation we need to scan the entire buffer pool. And you can see if you have normal size servers, this is really fast. But now customers are starting to use some servers with really large amount of memory. For example, we have some servers with 3 terabytes of memory. And then this can really take some time. And maybe the most critical ones is for failovers. So we had one very large database on the last server where this buffer pool scan, this was in 2019, this buffer pool scan was taking 3 minutes after failover. So it took like 3 minutes longer time for the failover to occur because of these buffer pool scans. Right? That's not good. So what did Microsoft do? Okay, so before in 2019 and previous version, then this was just like a serial process, just using single CPU. Now it's a parallel process. I don't have any measurements here, but it should be much faster than before. If you want to measure this, there is an extended event that they even made available in 2019 in some of the CUs and in 2022 also, this one here. And then you can actually see those operations, how long time they take. So if you want to compare before you upgrade and after, then you can look at this data and compare. Or look at those events. It says how many seconds did this buffer pool scan take, and yeah. I'm not sure if it says how many CPUs also, how many cores, I'm not sure, but at least you can see how many seconds. So all this is like features, you don't see them, but they are, really good performance improvements. Okay, now getting into ADR. So, yeah, let's take a step back there. This was introduced in 2019. And it's been further improved in 2022. So, what are they trying to solve with this feature, this ADR? So basically, there are 3 things that they're trying to solve with it. They're trying to make recovery faster. So they're promising, you can say, constant time recovery for database. For example, when database is starting up. Maybe some of you have seen recovery is taking a really long time. You can see in the error log, how many %, and then you just, can wait for hours sometimes if, server got restarted in the middle of a big transaction or something. So now with ADR, this should be constant time, basically instant. The other thing is rollbacks. If you have a large transaction, rollback can take a really long time. And with this ADR, rollbacks are basically instant. So that's a really good improvement. I can tell one story. So we were having a really big table, a really big database, and a really, really big table. And we have a change request from developers to change the type of one of the columns. And it was running running for a whole Saturday, maybe 10 hours, something like that, 8-10 hours, something like that on a Saturday. And then, we thought what to do. DBA was calling me and, what to do. And we decided to abort it. And then this rollback was running all until Monday lunch, this rollback. And, it was a critical incident, systems were not working because of this, the table was locked. So, this could be really, really critical. And it's very, very unpredictable also how long time it will take the rollback. And with this feature, you basically get instant rollback. Apart from that, it also have more aggressive log truncation, so transaction log will not grow so fast or so much. So this is really good improvement. they did this by introducing something. I will not go into the details here, but they introduced something called a persistent version store. So basically, we had a version store in Tempdb for a long time. Now we have this persistent version store that's like inside the database, right? There are some performance overhead. I mean, nothing is free. You get some of those really nice benefits here. There are some performance performance overhead of this feature because you need to log all those versions. If you already had, you can say, the snapshot-based isolation level or options like snapshot isolation allowed or read commit snapshot enabled before, then the extra overhead is very small, but yeah, there's some overhead. We have enabled it on almost all of our databases. There is some further improvement in 2022. So all this version, like, they need to be cleaned up, right? Every time there is an update to delete, it will like generate new versions. They need to be, the old version, they need to be like cleaned up. And before, there was only like a single thread for the server. Now it's like one thread for each database. So this was like good improvement they did in 2022. There are a number of other improvements also, maybe 5 other improvements that is a little bit difficult to understand if you're not engineer in the EDR team. It's a little bit difficult to understand exactly what they're doing, but some further optimization. And we also had some support cases where we run into some issue and some of these things should have been improved or fixed. There is one thing to be aware of, and I think that is still an issue, and that is if you have a long-running transaction. So let's say that you have 10 databases, you have a long-running transaction in one database. What happens then is that this persistent version store cannot delete the old versions. And that's actually not only for that database, but that is for all databases on the same server. So then this persistent version store will like start growing. So let's say if, for example, we had one incident where, because of some bug in some application, there had been transaction running against one small database for 3 days. That's got really bad, right? But it happened. Now we have monitoring of long-run transaction, but we didn't have it at that point. And then this persistent version store starting growing on another database on the same server. That was having a lot of activity. So suddenly we have 300 gigabyte persistent version store. And that can also affect performance of queries. So you have to be careful about long-running transaction if you're using this extremely long-running transaction when you're using this persistent version store ADR. Any questions so far before we proceed? Yes? So the question was if you get database bloat. So the question is if the size of the database is increasing when you turn this on. I would say that if you turn this on, I would not say that. Of course, this persistent version store is stored inside the database, but I would not say that it's significant. We have not seen that. The benefit you see, I would say the other way around, that since the transaction log has since you have more aggressive log truncation, then the size of the log are typically smaller when you're using this feature. Yeah, a question there? Okay, so the question is if I recommend having the persistent version store in a separate file group. We have not been configured like this. I think it depends on disk systems and so on. I mean, I'm sure there could be performance benefits of having, separate disk system for this persistent version store and so on. We have not configured like this, but I think that's a possible optimization that you can do. Microsoft recommendation to do it in a separate file. It was a question, or you're saying that it's? It is. It is. Okay. So, yeah, gentleman here is saying that it's a Microsoft recommendation. I still think, it depends on your disk system. If both of the file groups are going into the same disk system, yeah, maybe there's a performance difference. Maybe not. I'm not sure. We have not been doing it. Okay, let's move on here. So stack dumps. So Okay, so how many of you are aware of stack dumps? Okay, so I will give a little bit of background. So basically there are, you can say, stack dumps, you can get them automatically in SQL Server if there's some kind of bug. There could be an exception. There's something called a non-yielding scheduler. It's like a situation where Microsoft think that in order to find out about the issue, we want some more information, and that's why they generate this memory dump, or stack dump is also called. You can also generate them on demand. There is a command here called dbc stack dump. So sometimes maybe if you're working with Microsoft support and maybe they're asking you, let's say that you have a, some kind of special situation, they might be asking you, oh, can you generate a stack dump? Okay, then you can run this command here, right? Okay, then before going into the improvement, I will also say that there are like different types of dumps. By default in SQL Server, you get something called mini dumps. That's very small and typically fast to generate. But they only contain limited information. So in many cases, Microsoft support have difficulty in finding out about the issues, the real root cause based on those mini dumps. There's also something else called filter dumps. Have any of you generated a filter dump? Okay, so these are dumps that is much larger, contain a lot more information, but gives Microsoft better possibilities to find out about the issues. And these can be really large. They can be on large servers, they can be hundreds of gigabytes, those dumps, and take a really long time to generate. Okay, so before this was a serial process. Now Microsoft has made it, if you have CO8 and you have this trace flag here, it's a parallel process. And they also compress the dumps in memory before writing to disk. So, and if you want to see how good it's working, so here's one dump that we generated, a filter dump. You can see there's like every time there's a dump, it's right into this log file here in the error log directory. And you can see here that you get a compression rate of 92%. So it's really convenient. I mean, it will be faster to generate the dump, faster to handle, more easy to upload to Microsoft and so on. So yeah, not a well-known improvement, but really great. Okay, so now we're going to go into some of the more optimized, or they call it now intelligent query processing improvements. So have you heard about this feature, PSP? Yeah, I think if you attended some Microsoft presentation and so on, I think it's one of the big features of SQL Server 2022. So just for those of you that don't know about it, what they're trying to solve is they're trying to solve a parameter sniffing problem, right? And it's always been, before this feature, always like this, that, one query at a single point in time, it can only have like one plan in cache. And sometimes that could be bad if you have like, let's say that you have, order table, one customer with one order, another customer with 1 million order, they need different plans. But SQL Server could only have like, one plan in cache, right? And sometimes you could be unlucky that you get like a plan that is like for very, let's say that you get a plan for the customer with 1 million orders in cache, right? That is not good for all the other ones. Then it would be maybe get index scans all the time, right? So it's like the old classic problems. And sometimes you then have to do a recompile on the query on the store procedure, and then you got a good plan again, and so on. So what they try to do now with this feature is they basically try to have multiple, you can say, plans in cache for the same query at the same time. So they basically take one query and break or split it up, you can say, into multiple buckets. And in example with orders, you can say that, let's say that you have, some customers with huge amount of orders, some customers with very small amount of orders, and some customer with medium amount of orders. And these three buckets can have, different plans that is optimal for them, right? Then you can basically keep 3 plans in cache at the same time. So when a query is coming in, it's looking at the parameter, try to find out like in which of those buckets it belongs to, and then it's generating a plan for that. So there are some limitation. It only works up to, like you can see, 3 predicates, 3 parameters. It only works for equality. Does not work for greater than or smaller than. But yeah, still a very nice feature. I'm sure that Microsoft will continue to improve in this space. You need to have the compatibility level. So you see here's some performance improvement that's actually affecting the plans. That's why they have it behind the compatibility level. And that's of course because, you know, all this optimized improvement, there are, you know, might be super good for 99% of the cases, but there is a small risk of performance regressions. And to make it safer for customer to upgrades, they are like, you can say, putting those improvements behind the compatibility level. So you can upgrade, keeping the compatibility level, and then later you can change the compatibility level and, you know, see that it works well. And if it doesn't work well, then you can always move back. Yeah, this is just a drawing I got from documentation. So this is just talking about some kind of book listing, but it's similar to the example I was saying. A question here?
Yeah, 2 questions. One's related to PSP.
Yes?
Which is
Okay, so the question is, if you're on 160 compatibility level, and then you're switching back to compatibility level, I mean, you get some of those PSP query variants and plan generated, and then you turn back, you switch back to compatibility level, what happens? To be honest, I'm not sure. I'm not sure what will happen in that scenario. I would hope that it will not use those, you can say, PSP features anymore. But if that's really the case, or you need to do a clear of the procedure cache, I'm not sure. That will need to be tested.
And the other question was about ADR.
Yes?
Is it an enterprise-only feature?
I'm not sure. I'm not sure. Maybe I can get the questions afterwards if you can write, or if you can write me a mail, then I can find out about it. But I'm not sure. I'm not sure. I do know that this feature was. I know this was developed, this feature, because you know, in Azure, you know, they have similar problems in Azure for Azure SQL database, and Microsoft is giving like you know, SLAs for availability and so on. So it's not good at all for them. If failover was taking a long time, and recovery is taking a long time, I think that was one of the drivers for developing this feature. They were having experienced this kind of issues in Azure. Okay, so the question is, how is this PSP working with the monitor system and is causing any problems? So actually how this is working is that if you're looking in the, I mean, if you look at the plan cache or if you look at query store, you can actually see that there is like the parent query that looks normal, and then you can see those query variants that also, you know, is like query entries where they basically have, you can say, added some text in the end indicating some information about these query variants. So they are fiddling with the query text, and if that's causing problem for monitoring system or not, I'm not sure. I'm not sure. I do know that there are one thing I can. Yeah, this just if you want to look in Query Store, how often you're getting this, how many queries that is actually getting this PSP, you can actually just look at this Query Store query variant. Then you can see that. About monitoring, so one thing that I do know is that when you're working with Query Store, so let's say that you have one application that's issuing one query. You can say before, you can say in 2019, when you didn't have this PSP feature, then it was like, okay, one query for the application was like one query in Query Store and one query text. Okay, in 2022, it's much more complicated because then for this, still one query from the application, but that will go into one parent query in Query Store, and then you have those child queries. And all of those will, you can say, if you look at this query store, what's it called, query store query DMVs, then all of those will appear as queries. And it also means that if you're looking at, for example, those dashboards in or reports in Management Studio, then basically you can say, let's say that you look at top 10 queries. Then it might be that, you know, maybe 3 of them is actually the same query, right? Because you know, it's like been split up into multiple, right? So you need to rewrite, if you really want to aggregate those query variants into one, you actually need to, you know, rewrite the queries that you're using to, you know, analyze the data. And Management Studio has not been doing that, and there might be other, you know, systems that's also not been doing that. Okay, going into a memory grant feedback. Okay, so this is a feature that Microsoft, I mean, you know, was coming already in 2017, and they continued to improve it in 2019 and now in 2022 as well. So basically, the problem is that, you know, when a query is, you can say, a query is allocating some memory, and sometimes it's allocating, you know, too much, and it's like wasting memory. And sometimes it's not allocating enough memory, and if it's not allocating enough memory, then you will get this spill to Tempdb, and that costing performance, right? That's the problem they're trying to address. And I think the second problem is the worst, because that could give really bad performance. So basically, they try to see that, okay, let's say that you have one execution, and let's say that you didn't get, you know, there was not enough memory for that. And then for the next execution, it shall like learn from the first execution. That's why they call it feedback, because it's like a feedback loop, right? So this is like the, you know, the promise of this feature, what they're trying to solve. And I think it was coming, yeah, in 2017 and then 19, and then in 2022 they tried to improve it further. So one problem before was that you can say everything was just in memory, so that whatever it learned from this feedback loop, if there was a failover or you restarted the server, then it's like had to start from zero again. That meant like the first execution after failover, after restart, you know, was bad. Then you had this spill again, for example, right? And then after, you know, a few more executions, it was, you know, getting good again. But it's of course not good that the first execution is always bad, right? So that problem they have solved by introducing persistence, meaning that instead of just doing this in memory, they are storing it in query store, right? So this is one of the new things. Now they're using query store not only for like monitoring queries, but like the core part of the optimizer, you can say. The other improvement is something called percentile. So before it was just losing, you can say, the amount of memory from the previous execution was like using for the next execution, right? And that was working well if it was about, you know, same amount of memory that was needed every time. But if it's like changing a lot, for example, depending on parameters, then it was not working well at all. And then after some time, it was like giving up. It was just changing back and forth, and then after some time, it was giving up. And now, instead of just using, you can say, the memory from the last execution is using a percentile. And it's optimized for avoiding spills. So it should be working. I have not been measuring this, but it should be working much more smoother now compared to previous versions. Anyone have any experiences? Yes, please. Yes? Okay, so question is, what about this new optimizer improvement? Do you need more space in Query Store? I would say for those feedback features, from what I can see, it's a very small amount of data it's actually using. For the PSP, I was concerned about that before we started using it, because basically it means that for every, what used to be one query, will now be multiple queries and multiple query text and multiple plans and so on, right? What it looks like is that PSP only kicks in for a small percentage of the queries. So we have not observed it makes any real difference. But potentially, if PSP was kicking in for a lot more queries, then that could make it use more space. But so far, we only seen it for a very small percentage of the queries that's actually using it. So I don't think you should be concerned about that. So if you want to see, this is just about this percentile. So in the old day, you can in 2019, you can get this problem that if it was very different memory requirement, different executions, then it was like just going up and down like this. And now you can see here with the, you can say here percentile granted is working much more smooth. So this is really nice improvement. And here you can see it. There's this feedback table, query store plan feedback. We can look at all these feedback things. So you just filter on the type of on the feature you're interested in, and you should look for feedback valid, and then you will see things like this. Oh, this plan ID here will need this amount of memory. So like SQL Server finds out, okay, through this feedback loop, this is the amount of memory this query needs. And then whatever comes to query execution, this is like what the amount of memory that we'll be using. This means also that in order to get those two improvements here, you need to have query store enabled. Otherwise, it will not work. There are some extended event that you can use if you really want to troubleshoot. There's also some extended event you can use as well. Okay, then we have this feature called DOP feedback. And so this feature is actually not part of the compatibility level, not part of compatibility level 160. I guess Microsoft was not really, at the time of the release, I guess they were not confident enough to include it in compatibility level 160. So it's just one of those database scoped configurations. The other one's also database scope configurations, but this one is not like on you can say as a part of the compatibility level. So you need to enable it explicitly. And you also need query store on. So what it's trying to do is that, I mean, you have this max stop or different levels. You have it on the server level. You can have it on the database level or in, also even on the query hint level, right? And sometimes it can happen that maybe the parallelism is not that efficient. Maybe you have, I don't know, very high DOP, but maybe it would have been a very high max stop, but maybe it would have been, just as fast with a smaller DOP, a smaller max stop, right? And then just wasting resources. That's like the idea of this feature. And what they try to do is they try to analyze the queries, and they are looking at, elapsed time, they're looking at CPU time, they're looking at the weights, and then they try to assess based on that, was the parallelism efficient or not? If it looks like it was not efficient, it's like try to scale down the parallelism. Say that, okay, we had maybe, I don't know, max stop 8 before. It looked like it was not that efficient. Let's see how it performs with max stop 6 maybe, or DOP 6. Right? And then say that, okay, was it just as fast? Okay, then great, then we can run with 6, save some resources. It was slower, then it's reverting back to 8. That's like the idea. We have enabled this on all our databases in production and also in other environments. And across all databases, only kicked in for one single query across everything. Across, I don't know how many queries, but huge number of queries. So at least in our environment, it's not really made any impact. It might be that it just works, means that the parallel just works super good in for all of our queries, or I don't know. There may be Microsoft has more things to improve there. Have any of you been trying out this feature? No. So it's not causing issues, but yeah, only be doing something for a single query. And that's the nice thing now with the Query Store. You can actually see these new optimizer features. I mean, when they actually kick in, when they're doing things. I mean, that was difficult for other features before. And again, you can check it in Query Store here. Here's just a query for that. Okay, so we're going to look at one more of those feedback features. I guess most of you are familiar with canality estimators. Okay, so basically there's the old canality estimator. That's now called legacy, and there's a new one. That's not so new anymore, but was coming in 2014. That's called a default CU. And you can say that, this is all about finding out the optimizer or SQL Server trying to find about for a query or a part of a query, how many rows is going to return, right? That's what they try to find out. And for that, it has certain, you can say, assumptions. I'm not going to go into details about that. There's like a whole white paper about all those assumptions. But basically, you can say the default CE comes with like one set of assumptions, like one package, you can say, and the legacy CE comes with like another set of assumptions, like another package, right? And I think that a lot of people, when upgrading or switching compatibility level after upgrading to SQL Server 2014, run into problems because those assumptions here were different, right? And maybe their workload was better with some of the old assumptions. I know it caused a lot of problems for many people and for Microsoft support and so on, right? So what's Microsoft been trying to do here? I think they realized that, okay, there's not just one package that's like good for, or one set of assumptions that's good for all the, all the queries or all the workloads. They're trying to make it more dynamic. So basically they are saying that, when they're executing a query, they try to see that, okay, is there one of those assumptions that seems like it was not that great? And then they're basically trying some of the other assumptions. And if it looks like they're working better, they like sticking to those. If it looks like they were not that good, they're like reverting back. And again, storing this information in Query Store. You need latest compatibility level here. And you also, of course, Query Store on. And what it's doing also is that, basically saving this as hints. You can say hints that already exist. So there is a table, let me see, this one here, the second one, Query Store Query Hints. We can look at things related to CE feedback. And then you will see things like in the bottom, where it says option, use hint, and so on. So it's like been generated by this feature. And it's really difficult to see, how much impact it does. We can see that it's, coming into play for some queries. Difficult to say how much performance difference it makes. But yeah, I think it's a nice feature. So you can look at both the feedback and you can look at the hints in Query Store. Okay, automatic plan correction. So this is actually an old feature that will come in 2017. So the idea here is that, I think most of you have experienced that, you have one plan that runs well, and then there will be a recompile, and most of the time it goes well. Sometimes you get a plan that was not so good, right? And then people are complaining about performance, and then you go in and do a recompile, and then you get a good plan, and then things are good again. So Microsoft was thinking, couldn't we do this automatically, right? And so what they do is that if you enable this feature, then you can say every time there's been a plan change, they are like evaluating the new plan after a certain number of executions. After you can say the new plan has, after the plan change, then it's evaluating it, saying that okay, how good is the new plan compared to the old plan? And if the new plan is much worse, meaning it's using much more CPU, there has to be quite a big difference for them to do anything. But if there's like a big difference, this is not documented the thresholds here, but there's some threshold there, then it will like revert back to the old plan, right? So this is a nice feature, and I can recommend using it. This is an enterprise feature. There are some further improvement in 2022. Before, in 2017 and 2019, they were just doing a single check. You can say after a certain number of executions. In 2022, CO4, they've improved it, so they're making actually 2 improvements. But basically, they're making multiple checks. So it becomes more reliable, more robust and more reliable. And that is behind trace flags, those improvements. And actually, the second one is after an issue that we reported, that where this was not kicking in, we were expecting it to kick in. And then they made this improvement, the second one here, with like an additional check after 5 minutes. See that, okay, how is the plan actually behaving after 5 minutes? I have some examples here, but we don't have time to go into that. The last feature here I just want to talk a few minutes about is query store hints. Have any of you been trying out query store hints? Okay, a few persons. Okay, so basically now in query store in SQL Server 2022, there is the way to, you can always been able to add hints to queries. I mean, in a store procedure or in a query and management studio, you can just add hints like, you can specify option, and then you can do recompile or a lot of other hints, index hints or force seek or all kind of hints, right? The problem is that sometimes you don't have access to the source code, right? Or maybe you have access to the source code, your developers have it, but it takes a long time to, create a new version of the application and so on. And you want to fix the problem immediately. Maybe add a recompile or an index hint or something. Then now with this feature, you can basically, you find a query in query store, you find out what's the query ID, and then you just do like this. You execute the store procedure here, you specify the query ID, and then you just specify which hint you want to add. Like, for example, option recompile. And if you want to remove it, you just do like this. There was something else before called plan guide, still exists, but this is like a replacement. That was much more difficult to use, but this is really powerful, really easy to use. And if you look at an actual plan, actual execution plan, you can actually go into the XML, and then you can actually see that, there's been one of those query store hints. If you want to see for sure what's going on, if it's coming into play or not. And here's just comparison if you want to know, okay, why use this query store hints over the old plan guide? There are a lot of benefits. The base is much more easy to use. Any final questions here? Yes, any online questions? So about automatic plan correction, does it only consider CPU, also other metrics? I don't think it's documented, but my understanding is that looking at CPU. But I can't say for sure. So with all this improvement, why stay on the old version, right? I mean, you can of course always say that if the system were running well on the old version, maybe you don't need all this optimization. But there are of course also good reasons to upgrade, and we have upgraded all our systems. It also depends on the requirement on the system. If you really want to push performance and scalability and so on, then there are good reasons to upgrade. If you have the same workload as before, maybe you're fine. A question here in the back? So what about automatic plan correction? So we have, is anyone using it is the question. So actually we have been enabling it for all our databases that are in Enterprise Edition, which are most databases. And overall it's working well. It's not kicking in and it's not solving all problems, but even if it's not solving all problems, it's solving some problems. I mean, it's still good. We found one issue, that the one I told you about before, and we found one other, I think 2 issues we found that we got fixed from Microsoft. So we have enabled it, and it's not caused any issues, and it fixed some problems, and Microsoft continues to improve it. So I can recommend trying it out. Okay, final question here. Okay, so the question here is about if you're using this feature, automatic plan correction, and it's like it's taking action. It's just like bad plan and it's taking action, do you get any kind of a warning or alerting anything? There's nothing like this built in. You could build your own monitoring. I mean, there are extended events where you can check it. There's also one DMV, I didn't list that here, but there's one DMV also where you can list it. Always like displaying what is done. I think this, there was one DMV here before, sorry, one extended event here before. That's very useful. Then you can see exactly when it's taking action. Okay, I think we're out of time. Thank you all for attending here, and I will be here all day, so if you have any more questions, I will be happy to take questions here afterwards, or if you see me out in the conference here during the day. Thank you all for attending.